All right, guys. Hey, welcome in. Obviously, I'm not here today. We're going to continue with our notes, even though I'm not here. Some things to think about based on what we talked about yesterday with our first day of boot camp with equations and solving equations. Saw those two-step equations yesterday. We really focused in on inverse operations, so doing the opposite operation to solve. We also really focused in on looking at that part that's not attached to the variable and moving that first. And so we're still going to use those things, right? Those inverse operations, the fact that it's an equation and keeping things balanced. We're going to continue to do that today. But we're also going to look at ways that we can simplify equations when there's multiple terms involved and when we can combine things that are like terms to start when we try to solve these, okay? So the first thing that I'll tell you guys as we get going with this is you want to make sure you have your notes here, go through some of these examples, and then the sub will give you a paper copy of your assignment, all right? Kind of similar like we did yesterday. Go through the notes video here first with me, and then you can kind of, from there, you can come up with your answer for some questions on your assignment, okay? So let's fill in these notes here first. So if we take a look at this first section here, it's kind of like we had yesterday, fill in the blank. So we're going to be solving equations by combining like terms. So those are terms that look very similar, right? When we have like terms, we're thinking about terms that are similar in terms of whether they have a variable, being the same variable, or no variable at all. So constant numbers without variables, those are ones we can combine. We're also looking for terms with the same variable or variables. We'll get to a point where we see multiple ones that we can combine, okay? So the first blank here, it says blank like terms on the same side of the equation. That's where we're going to combine. Okay, oops, combine. Let me redo that one. I kind of started to write that a little bit off. There we go. Combine like terms on the same side of the equation. So that's the important thing, right? The terms that are on the same side of the equation that we can combine. And we're looking at, right? And then we wanted to isolate the variable again, right? Isolate that variable using inverse operations or solving. Inverse operations by solving, okay? So we have some examples here that we're going to take a look at. These first two when we think about this. So make sure that you are thinking about those things, right? We want to combine the terms that are like on the same side of the equal sign, the same side of the equation, and then we're going to isolate the variable by using inverse operations and solve. All right, so I'm going to draw a line down the middle, remember, of my equation. We talked a little bit about this yesterday. The reason I do that is just to remind myself as I'm doing this, right, as I'm looking at this, I want to be able to know and understand that if I'm performing an operation on one side, right, if I'm undoing something on one side of the equation, I want to undo or perform that same operation on the other side. All right, so our first step is to combine our like terms. So we're going to look at this side of the equation over here, right, the left-hand side. I have a 5x, a minus 6, plus 4, and all of that should be equal in value to 12 when I'm looking at this. So my first thing I'm going to do is combine my like terms. So I'm looking at a 5x and a 4x. Both of those are positive here, right? So 5x and a 4x, and make this a little bit skinnier so it's easier to read, okay? But both those are positive. They're like terms. They're both x terms. So those terms can be combined before we try to do any sort of inverse operations or solve, okay? So I have a positive 5x and a positive 4x. That gives me 9x's. I still have the minus 6 over here. This is by itself. It's an isolated term. It's by itself right now because there's no other constant or normal number terms. And that's going to be equal to 12. Okay, so now this looks a lot like, right, if you think about it, it looks a lot like our equations from yesterday, right, a two-step equation. So I've got a 9x after I combine the 5 and the 4x. Those are both positive, combine them. Minus 6 equals 12. So what I'm going to do first is I'm going to look at that part without the variable, right? We talked about this yesterday when we do our two steps. And I'm going to perform the inverse operation or undo this part here first because I want to eventually get to x equals something in the end, right? Okay, so if I want to undo the minus 6, I'm actually going to add 6 to both sides, okay? And so what I'm left with then, right, is the 9x that stays because that was not a part that I added 6 to. And that's equal to, if I go to 12 plus 6 over here, 18, which is really nice because then my last step here is a 9x. That means it's 9 times x, and that's supposed to be equal to 18. So in order to undo or get rid of the multiplication step, I'm going to divide by 9, right, on both sides. And so 1x, when I divide 9 by 9, 1x is equal to 18 divided by 9, which is 2, okay? Which is 2. And I can always go back and plug this in, right? If I plug in x of 2 in my original equation, this would become 10 because 5 times x is 10, right? 5 times 2 is 10, minus 6, and then plus 4 times 2 is 8. And that should equal 12. Well, if I do this, 10 minus 6 is 4. 4 plus 8, that does equal 12. So it checks out, and I know that I did it correctly. All right. At this point, I want you guys to go ahead and pause the video and try number 2 over here. Kind of follow the same steps we did on this side and see what you get, and then you can unpause it and go through it with me. All right, hopefully you took a second there, a few minutes here to answer this second question here. First step is to combine like terms. So in this case, I've actually got 2 sets of like terms. I've got a negative 7j and a positive 2j. Those are like terms, right? Those are like terms, and they are both j terms. Even though one's negative, one's positive, they're both j terms. So I can combine those before I solve. And I can also combine a positive 8 and a minus 5 as well, because those are normal constant terms. Those are like terms without a variable. And so when I get my answer there for that, I can combine those as well. So a negative 7 plus 2, that's the first thing here, right? If I lose 7, but I gain 2 back, now I'm at negative 5j's. So that's what I get here as my answer for this, okay, negative 5j's. And then a positive 8 minus 5 would be a positive 3, okay? And then all of that still equals 38. Nothing changes on this side of the equal sign, at least not to this point. So then what I'm left with is a negative 5j plus 3, and that equals 38. Okay, so we're back to a 2-step equation once we get here, like we did yesterday, right? 2 steps from this point right here. So negative 5j plus 3 equals 38. So then I'm thinking the plus 3 part is the part without the variable. So I subtract that 3 from both sides, right, to get rid of it. And then I've got a negative 5j is equal to 38 minus 3, which is 35. And then this last step is a negative 5 times j, right? So to undo that, or the inverse operation, I would divide by negative 5. And then again, be really careful here. I'm dividing by a negative 5 to get j by itself. Isolate that variable. A positive 35 divided by a negative 5 would be a negative 7. So hopefully you got that answer as you work through it. All right, so we got a couple more examples here. When you take a look at this one, right? When you take a look at this one, it looks a little bit different. And the reason it does is because we actually have decimal values in this one for number 3. And then we're going to have fractions in number 4. That does not change, right? That does not change how we solve these. So we want to be really careful with that in terms of our answers here. We may need to bust out a calculator to help us out and answer some of these questions, but we do want to be really careful about going through and answering some of those. All right. So take a look at this first one. We have a 9 2/10 m and a negative 7 4/10 m. Those are my like terms together. And then I just have a regular minus 8 5/10, or 8.5. Okay, and that should be equal to 63 5/10, or 63.5. So if I look at this, the two that I can combine right here are 9 2/10 m and 4 7/10. All right, so as I look at this, I pull up my Desmos graphing or scientific calculator. I'll put the link for this in Schoology today if you guys need it. Or you can use your handheld calculator. But as I look at this, if I do 9 2/10, right, 9 2/10, and it's actually minus 4 7/10, I'm going to get 4.5 m. So 4.5 m is what I get when I subtract those two, minus my 8.5, and that's equal to the 63 5/10. Okay, so I do that first step. I combine my like terms. Even though they're decimal terms, I can still combine them, right, in order to solve and get my m value by itself. That's what we want in the end here. So 2-step equation that I'm down to right now, I've got 8 5/10 right here, right? And that's equal to 4 5/10 m minus 8 5/10 is equal to 63 5/10. So I'm actually going to add 8 5/10 to both sides for this, okay? And when I do that, I'm left with 4 5/10 m, so we're actually going to have to kind of be really close to that one. That's okay. And then we're going to come over here and add 8.5. So let's think about this. If I add 8 to this, I'd be at 71. And then a half and a half makes another one. So that would actually be 72. Okay, 72. So what I'm left with then is 4.5 m. I'm going to kind of write it up here, is equal to 72, right? This is a decimal. That's a whole number. That does not change our steps. So we added, right? And then a 4.5 m is multiplication. So my step here is to divide by 4.5, or 4.5. And when I do that, if I can't think of this off the top of my head, I can use my calculator again. So let's pull this up and get it here. So if I do, it needed to be 72, right, divided by 4.5, I get my answer, which is 16. So I can come back here, write that in. M is equal to 16, okay? M is equal to 16. So then I'm looking at, excuse me, this example. I'm going to do the same thing here. I'm going to extend this page a little bit so we can see it, right? I'm thinking like terms, so this is where we can get a little tricky, right? If we look at this, on this one, I've got 2x terms, and they're both fractions, right? They're both fractions, but I don't have common denominators, right? If I'm adding fractions, which is what's going to happen here, because this is a plus 3/4 x and this is a positive 1/8 x. If I'm adding fractions, I need common denominators. So let's go ahead and make this. This would be 1/8 still, right? Let's go ahead and make this out of 8s. And so if I do that, I need to multiply both by 2, right, to get this to be out of 8s. So let's do 1/8 x minus 3. And then if we switch this, now it's going to be 6/8 x. And that's equal to 4, okay? So I still have my like terms here, the 1/8 x and the plus. It's a plus 6/8 x. So let's write that down here, plus, we're adding that. So 1/8 plus 6/8 would give me 7/8 x, right? Minus 3 is equal to 4, okay, is equal to 4. So then I'm down to a two-step equation. After I've converted these fractions, right, to like denominators, right, common denominators, I've got 7/8 x is minus 3 is equal to 4. So this would be the part that we wouldn't move first because we're trying to get x by itself, right? So I'm going to add 3 to both sides, okay, add 3 to both sides. So I'm left with 7/8 x is equal to 4 plus 3, which is 7, okay? So then this is a tricky step, right? We're looking at multiplying 7/8 times x, right? So I would actually be dividing by that value to get my answer here, right? So I'd be dividing by that value. So if I kind of write it over here, let me do this. 7/8 x is equal to 7, right? We're dividing by 7/8. So a lot of times we don't really like to do that, right? When we divide fractions, it's really like multiplying by the reciprocal, okay? So we could write it like this and answer our question that way, but we are dividing and we're getting x is equal to whatever 7 divided by 7/8 is. So I can put that in my calculator again and do this. So if I do 7 divided by 7/8, and this is where we get a little tricky, right? If I hit my AB button, that's my fraction, I can do 7/8. Okay, if I do it like that, I actually come up with an answer of 8 as my final answer. So x is equal to 8. Another way to think about this, if you divide by 7/8, would be the same as saying 7 times 8 over 7, right? If we look at this, right? Because if we if we divide fractions, it's really like multiplying by the reciprocal when we flip these two, okay? And so if I do that and I come back and type that in my calculator, right, I should still get my same answer. So if I do 7 times its reciprocal, which is 8 over 7, I should also get 8, and that's what I do here, all right? So just because we get fractions right in here, just because we get fractions and decimals, that does not change the process. We're still combining our like terms with the same variables or no variables at all, okay? And we're still doing our steps to solve by doing inverse operations once we get down to that point.
All right, guys, so we're down to our last 4 examples here. And remember, I like to draw that line right down the equal sign here. Oops, it just zoomed in on me here real quick. So I like to draw these lines down that equal sign just to remind me that I'm keeping things balanced on both sides. So I'm going to walk through actually these first 2 examples. So the ones on the left-hand side with you guys really quick. I'm going to have you guys pause the video and try the last 2 over here just to kind of get you through these last few examples before you jump into your homework, okay? So again, what we're looking for this time around is those like terms that we can combine on the same side of the equal sign. So I like to identify those by underlining them and circling them, those kind of things. But when I look at this one, right, I've got a 7x and a minus 2x. Those are like terms. Those are both x terms. Those are terms with the same variable, parts with the same variable on the same side of the equal sign. So 7x and a minus 2x would leave me with 5x's, okay? I still have that minus 2 that's kind of by itself. There's nothing that's just a normal constant number on this side of the equal sign. So when I look at that, I'm now left with a 2-step equation, okay? So I combine my like terms, and now I'm going to solve like I have been with these 2-step equations. So what I'm looking for, since there's a 5x and a minus 2, right? Minus 2 is the part I want to move first. I eventually want to get x equals something, right, as a final answer for this. So I want to get rid of the part or the term without the variable first. So instead of subtracting 2, I'm going to add 2, right, to eliminate it from one side, keep that equation balanced, do the same thing on both sides of the equal sign. So I'm left with 5x is equal to 8 plus 2, which gives me 10. My final step, since it's 5x, that is a multiplication step, right? 5x's, 5 times x is equal to 10. So if I divide by 5 on both sides, I'm going to get my final answer. And I should get x equals 2 for this one. X equals 2, okay? If I look at this one over here, kind of the same thing except for my terms that I want to look to combine. There's multiple terms on the right-hand side this time. So I've got a 6x and a minus 7x and then a plus 11, okay? So I kind of identified the ones that are like terms by marking them the same way here. Be really careful, right? If you have a 6x and then minus 7x, 6 minus 7 actually ends up being negative 1 or just negative x, okay? And I'm going to put a negative 1 there. I'll show you why here in a minute. And then plus 11, because that constant term stays the same. It's not changing. There's nothing combined with it, and it still equals 13, okay? So now I'm left with something that looks like this. And again, I want to move the part without the variable first. So I have a negative 1, and that's a negative 1 times x, right? Negative 1x plus 11. So this plus 11 is what I want to move first here. So I'm going to subtract 11 from both sides first. When I do that, I'm left with 2 equals negative 1x. I'm not finished though, because I don't want a negative variable, right? I don't want a negative final answer, okay? So what I'm doing here, right, what I'm going to do here is think, okay, this is a multiplication step. I still want to get x by itself, so I actually need to do one more step, and it's to divide by a negative 1, okay? And that's fine, because then my final answer over here, x is going to be equal to whatever 2 divided by negative 1 is. That's a positive 2 divided by a negative 1. So I actually end up with a negative 2 as my final answer, because a negative divided by a positive, or sorry, a positive divided by a negative, when you have one of each and you multiply or divide, that final answer is going to be negative. So I get a negative 2. All right. These two have fractions, right? And I think I just said I was going to do these two left ones, but these two have fractions and decimals. So I want you to actually pause the video and kind of challenge yourself here and see what you can come up with, and then come back to it and we'll go over them and answer the questions together. All right. Hopefully you took some time there and kind of work through them. Let's take a look at this, right? And when I do this, I'm going to go ahead and identify those like terms right away here. So I've got a negative 9 and 8/10 k and a minus, right, 4 and 7/10 k. So this gets a little tricky. These are both negative values. So again, you might want to use your calculator here, right, to do this. So I'm going to think I've got a negative 9 and 8/10. Whoops, hit the wrong button there. 9 and 8/10. It's still popping up for some reason. There we go. Negative 9 and 8/10. And then I'm going to subtract, right? I'm going to subtract when I'm going through this and answering this. Maybe I should have made that a little bit bigger. 4 and 7/10. 4 and 7/10. Okay. So when I go through and I answer that and I'm looking at this, what I'm left with is a negative 14.5 or negative 14 and a half, right? K minus 4 and 3/10. And that's equal to what's left over here, which is that 3 and 4/10. 33 and 4/10. So I combine those like terms, right, guys? I combine those like terms, and now what I'm left with is a two-step equation. I want to get rid of the part without the variable first, so that would be, in this case, this minus 4 and 3/10. Okay, so I'm still going to have that negative 14 and 5/10 k, negative 14 and a half k over here, but I'm going to add 4 and 3/10 to both sides. Okay, add that 4 and 3/10 to both sides. When I do that over here, I'm left with, when I look at 33 and 4, that's 37. 4/10 and 3/10 would be 7. So I'm going to have 37 and 7/10. Okay. And then my final step here, this is a negative 14 and a half times k, right? It's a multiplication step. So my final step to get k by itself would be to go ahead and divide by that negative 14 and 5/10. I'm going to do that on both sides to get my final answer. So k should be equal to, and here, if I can't see this, I might use my calculator again. So let's try that and clear all of this out. Okay, and I do 37 and 7/10 divided by negative 14 and 5/10. Okay, and when I do that, right, 37 and 7/10 divided by negative 14 and 5/10, I get a negative 2.6. So again, I get a negative final answer because it's a positive divided by negative. Don't have a whole number answer, but that's okay. I'm getting a value that would make this equation true based on what those steps are when I go to solve. All right. One final example here. So I've got two fraction parts, right? I've got two constant parts that I can combine before I start anything here. This is where it gets a little tricky, right? If you think about this, I've got 1/8 x and negative or minus 3/8 x, okay? I'm already good in terms of trying to combine these because they have the same denominator, but I have a 1/8 minus a 3/8. So if you can't see this or you can't think about it, you can use your calculator again. So let's jump back here. I'm going to use my fraction. So if I do 1/8, right, and I actually subtract that, right, subtract it by 3/8 when I answer this, okay, 1/8 minus 3/8 gives me a negative 0.25 if I click the fraction button here on this calculator. And remember, I'm going to put this link into Schoology today so you guys can see it. If I put it on my calculator, negative 0 and 25/100 or 0.25 is actually the same as saying negative 1/4. Or if you think about it, right, negative 2/8, right? But they go ahead and simplify that for us when we answer it. So we'll go ahead and do that here too. So we'll say negative 1/4 x is what I get when I combine those two. And then I've got a minus 4 and a minus 4. These are two negative values. So if I lose 4 and then I lose 4 more, that's actually like minus 8. And all of that should be equal to 5 when I answer this question, okay? Again, once I combine my constant terms and my fraction terms with the variables, now I'm down to a two-step equation. I've got this negative 1/4 x and this minus 8. So the part that is not attached to the variable is this minus 8. So I'm going to move that first or undo it. Subtracting 8, opposite of that, inverse operation is adding 8. Okay, so I've got a negative 1/4 x left, and that's equal to 5 plus 8, which is 13. Okay, this is a multiplication step. So in order to solve this, I'm really dividing by a negative 1/4. So I'm taking this and dividing by a negative 1/4 to get my final answer for this. All right. So if I go through and do that, I'm going to get x is equal to a positive divided by a negative. And I don't know what that is off the top of my head. So I'm going to go ahead and say, okay, so if I look at this again one more time, it's 13 divided by a negative 1/4, right? So we got to be really careful here. Should be a negative final answer. So I'm going to take 13 divided by, and I'll put my negative sign here and then my fraction 1/4. Get my final answer, and I actually get negative 52. Okay, negative 52. And why does that get bigger, right? If you divide by fractions, it's really like you're multiplying by its reciprocal. We talked about that with one of the other early examples. If I'm taking 13 of something and dividing it into fourths, right, pieces that are fourths, I end up getting a lot more. And it's a negative value because a positive number divided by a negative number gives me a negative value, okay? All right, guys, so when you think about this and you kind of work through this today and you're going through your steps, make sure you think about what we did yesterday with our examples, but then also understand you're going a little bit further with this. You're actually combining terms that are similar on the same side of the equal sign and then going through and doing your inverse operations to solve. You should be able to get that worksheet from the substitute. Make sure you get all of those 16 problems done, and we will turn those in tomorrow in class. All right, thanks for working through the notes, and make sure you get all of your practice problems done on that worksheet. See you tomorrow, guys.